Good morning. Welcome to episode 94 of the Driller Newscast, a weekly update on the news and stories impacting the drilling and water industry. I'm your host, Brock Yordy, and this week in the news is going to be our safety topic, where we talk about how much we were impacted by Winter Storm Heather and what OSHA released for our weather preparedness plan. And I want you to think about that challenge I gave you last week in episode 93 on how did your company fare out? Because let's face it, this was a bad storm that affected 200 million Americans. We saw 20-degree temperatures in Houston. We saw 30 below temperatures in the Northeast and the upper Northwest. And we, as professionals in the construction industry, in the drilling industry, need to start thinking about extreme weather and how it impacts us, from floods to lightning to heat exhaustion to extreme cold. For our feature this week, I sit down with Dave Bowers, instructor and creator of the Local 150 Operators Union apprenticeship program for geothermal drillers, geotechnical drillers, and water well drillers. We sat down at the NGWA, International Ground Source Heat Pump Association convention in December in the climate control booth. We had a great discussion about geothermal drilling 101, and now I'm going to bring it to you today. I hope you enjoy. For this week in safety, we just had one heck of an entire country winter storm. And OSHA had released, some winter weather prep, what we need to be thinking about. No different than when we have those big heat waves in the summer and we talk about climatizing our employees, making sure they have the right PPE and practices in place. We need to think about what just happened, how we worked, who got injured, how we triaged these extreme temperatures. 25th of December is 52 degrees in green in Michigan. Now, as I'm filming this, it's insanely cold, though we see a brighter future of 30-degree weather again here in Michigan. So this is what OSHA states. Employers can implement to protect workers from injuries, illnesses, and fatalities, including implementing cold weather protocols. This starts by providing workers with the proper tools and equipment to do their job, developing work plans that identify potential hazards, and the safety measures that will be used to protect workers. So go back, think about that extreme weather, the hand injuries, the slips, the trips, and the falls, how we treated our equipment when the high of the day was 14 degrees. So we need to start thinking about what could we have done differently, like scheduling maintenance and repair jobs for a better time of the day, the week, where there's the least amount of exposure to the cold weather. We need to think about avoiding exposure to extreme cold. And I want you to think about that, how we expose our workers to that cold weather and how we avoid exposure and how we can possibly limit that exposure. So right now, I want you to take a moment, think back to last week. And was there some jobs that we absolutely had to be on? Those situations where we find ourselves in an out of water for a farm or a family, and it's immediate that we need to get out there and help them get water back, especially our customers with, large cattle operations, chickens, pigs. We haven't been prepped for this year. So here we are, and we have to start thinking about what limits our people to being safe and how do we operate there? with 52-degree days in December, what was our glove situation? What was our winter weather gear like? Were we still vests and sweatshirts in the truck? Or did we have that heavy duty Arctic gear? Were we thinking about how our tooling is going to react in those cold temperatures? These are all things that are very important to our operations. Next, ice, slips, trips, and falls. Operating on those farms where, there can be an incline to where we're going to get to that pit. How are we going to move there? Slips and trips can be a major hazard, especially in the winter weather. Okay, let's talk some cold weather exposure. I want you to go to the NIOSH page. I want you to go to OSHA. I want you to look at what those extremes look like and how we react to them and what that next situation can look like. Are we providing warm areas for our people during breaks? Do we have warm liquids? Those are sugary warm liquids. No, that's not a nip from some sort of tin can that's got a schnapps, or we got that St. Bernard with the barrel. That's not what we're looking for. We need our workers monitoring each other and thinking about who's at risk of cold stress. How are we monitoring our weather conditions during a winter storm? Do we have a reliable means of communication with workers and being able to stop work, evacuate when necessary? It sounds a lot like our lightning situations or our extreme heat. OSHA states acclimatizing new workers and those returning after time away from work by gradually increasing their workload and allowing more frequent breaks in warm areas as they build up a tolerance for working in the cold environment. Cold stress and heat stress, it's the same thing. We're taking the core body temperature down, talking about below 95 degrees to get into hypothermia, whereas we're looking at that core body temperature bumping up beyond that 98 to 102, and what's happening to our bodies. What are our means of communication with workers, especially in remote areas? Do we know how the community warns the public about severe weather? This is summertime. We're thinking about outdoor sirens, that radio alert. We need to download access to the National Oceanic Atmospheric Administration, that's NOAA, who provides multiple ways to stay informed about winter storms. When we are notified of a winter storm watch, advisory, or warning, what are our people supposed to do? What is the instructions? Think about what the local authorities say. NOAA's weather radio cold situations. I want you to think about their weather radio and how cold stress steps in, and then how that's going to impact our body and how we can lose heat faster. That's why we're having, skull caps in with those hard hats, hearing protection to keep the bottom of the ears. Think about prolonged exposure to cold and what our body does to overcome that. Last week was tough. We're not out of this. The jet stream dips differently now, and we're seeing the mid-con, we're seeing Oklahoma, we're seeing Kansas, we're seeing Missouri, Nashville, big snowstorms. What are our operations and how are we going to mitigate that risk? Go out, be safe. Hi, this is Brock Yordy live in the IXPA Pavilion of Groundwater Week. This is the International Ground Source Heat Pump Association in conjunction with the National Groundwater Association Convention. And we are live in the Climate Control Group and Climate Master booth. And we've been talking all things drilling and geothermal installation. And I have a great industry friend and colleague with me, Dave Bowers, and I'll let him go ahead and introduce himself. And we're going to talk geothermal 101. I'm not just a pretty face here. I'm actually a drilling subject matter expert, and I love talking drilling. And Dave and I have done this for many years, and now we get to do it with the Climate Master folks.
Hi, Brock. My name's Dave Bowers. I have been tasked with doing training for a labor union in northern Illinois, northern Indiana, and northeast Iowa to put together the first and currently the only geothermal water well and geotechnical registered apprenticeship by the U.S. Department of Labor, DOL. There is. So that was kind of a big ask. Didn't really know what I was getting into, but it has been a wild ride. So, I'm excited. I'm excited for what we have coming up. I'm excited that to share what knowledge that I have. And let me tell you, I agree. You're not just a pretty face, or really a pretty face at all. But, you do have a wealth of knowledge on some subjects.
It's always great when you go unscripted with Big Red here. And what we're going to talk about today is geothermal drilling 101. So what equipment am I looking for? How am I diversifying my business? How am I getting into this business? And so obviously the first step in this is looking at your area and the local geology and making a decision on the rig and tooling and piece of equipment that's best fit for your company. Drilling does not have to be complicated if it's well thought out and planned.
There's an old saying, the best drill for a project is the one that you have available to you. You just have to figure out, am I suited? What do I have to do to make it work? Or do I just step back and, you know what, we're not going to bid that type of work because we're not set up for it. And a big piece of that is understanding what your capabilities are. Every drill isn't capable of doing every type of hole, and every drill isn't good for every geology. Every process has its place. So you need to learn, for whatever area you intend to run in, you need to learn what is the best process for me to be able to be successful the most often. Because in drilling, as we all know, successful every time is a pipe dream.
That's very important. So if I'm starting a drilling company and I know nothing about drilling, there's plenty of places we can go to start learning the process. There's the Australian Drilling Manual. There's Marvin Glotfelty's book, Art of Water Wells. There's the Groundwater and Wells, basically our industry's, manuscript. There's plenty of content at thedriller.com that Dave and I contribute to. There are webinars and EDUs, and it's about starting to ask those questions. But now, if I go, what rig I'm going for, I start thinking about the area I'm in and the amount of risk involved. Let's say we're going to do residential geothermal and you are along the Ohio River. We're going to have big cobbles. You're going to have some casing issues. There's going to be some things that we need to start thinking about. So if I'm looking at that drill package, the rig and the tooling are just two parts of it. And then we jump into what is my drilling method? And that can be mud, that can be air, that can be reverse, that can be sonic, that can be augering. That's going to dictate the amount of time it takes for us to be able to put these boreholes in.
And not every drilling package will be able to do each one of those things. So what we need to do is we need to not only look at that geology, but we need to do training and we need to do research to know before we go there what the most likely is. And that's really all we can tell is the most likely, unless we have some sort of good geophysical data that has been provided to us about our project. But right now, that doesn't happen as often as it could. We'd really love to see it increase, but we want to look at what are the wells in the area, right? Do a little research, see who has drilled in that area. I may have experience myself in that area and you don't. Ask your peers, what have you encountered here, right? Because we're always looking to see how efficient we can be, and it's all pre-planning. It reminds me of a job that I had done a lot of research on, that you and I actually worked together on, and we had thought we had covered every angle. We brought everything that we thought we would need, and it still threw us a few curveballs, but we were ready for them because we had pre-planned. It was not as smooth as I'd like the job to be, and then the added stress of one of us having to leave the project because he was having a kid, right, which was a problem, but I'll let it slide because I actually like the kid that you had, so I'll let it go. But in reality, had we not done the early work on that project, and it was a repair on a geothermal project that somebody came in untrained and really over-aired the overburden and made it really, really difficult to drill. An area that's already known for being difficult, what they did is they came in with some specialty rigs and just aired through the overburden while advancing casing, but they blew everything apart to where now getting new casing in without using the same method, which is not what we wanted to do, made it very difficult. So we had to adapt. So all that pre-planning we did, saying what happened here, what are the problems, and how do we overcome them, led to a job that was successfully completed. Not as quickly as we'd like, but was successfully completed.
And so that's exactly it. We live in a very developed country. North America as a whole, the major cities and the places that we are going to drill have logs. We have data. We can look at topographical maps. We can look at the United States Geological Survey. We can get that. And that's it. Now, if I'm investing in equipment and people, what does my program look like beyond that rig and tooling? And it's information and data so that I can minimize that risk and start thinking about, can I be successful? So now if I'm going to have that drilling company, what is my win? Because I feel like the problem that I have right now with diversifying into geothermal or drilling in geothermal or the investment is everybody believes it needs to be that 500 or 1,000 hole project. It's about being able to get as many ground source heat pumps in as we possibly can. And that's why we're broadcasting live from the Climate Master Climate Control Group booth at Groundwater Expo Week, is because this is an important piece for us to get those boxes in place. So being able to understand my data and mitigate that risk and invest and know, maybe I just need to drill 5 holes this week. What is the utilization of this piece of equipment? It's a very important economical impact to diversifying.
Well, on top of that, some of this stuff might be new. Maybe we incorporate some technologies in geothermal that if we were historically a water well company, it's not greatly different, but it is still, the grouts are going to be different. We're going to be putting loops in the ground and leaving them sticking up, and the group reels themselves are a little bit different to operate, and there's some hazards. So anything that we're going to run new, we have to make sure that our crews have been trained on not only how to operate them, where are the hazards, where are the pitfalls for this stuff, right? And then how do we overcome that? It could be as simple as you know what? We're going to need, at the end of the day, we're mud drilling. We're going to need to evacuate all that heavy mud and get rid of it somehow. How do we do that? Do we have hydrovacs on site? How are we getting rid of it? Do we have a place for it to go? And then once we evacuate that, what weight would we need for this loop package to go down, right? Can I do it on my sand line with a weighted rod, or do I have to tape something to it? Am I set up properly, right? And looking at all those things and making sure the people who are going to the job have been trained on the intricacies of why this is different than the last job or the last 10 jobs. Because no two jobs are going to be the same. I remember a bad loss circulation job where you had introduced me to something called diamond seal. And, you know, it was counterintuitive to everything that I had ever dealt with before. But with a little training, it worked out. But it was a thing where had I attempted to do it just by reading the package and let it go, I don't think I would have been successful.
No, and I think that's a big piece on this entire situation, is that we don't have to go at anything alone. That's why we have this community. That's why we have groups of driller communities. That's as we get on LinkedIn and Facebook and we make those connections, and let's talk drilling. And that's a very, core piece to this. Loop installation package, as we move on to what this looks like in an urban environment versus, out in a big suburb residential properties with a couple acres, is going to change how we do this. And we as an industry need to start simplifying what that installation package looks like, what our depths are, and that's going to maximize our equipment and our utilization. Mind you, we have to match that with our subsurface geologies and the thermal conductivities, those principles. We don't need to go at this as everything's a rule of thumb, but we need to understand that 6 300-foot holes may be easier than trying to do 3 550-foot holes, and the complexities that go at that and the amount of risk. And that's another reason why I have Dave here, is the more we simplify it, the easier it is to replicate and train and get a staff that can be successful to set them up and mitigate that risk.
Well, one of the things I always like to say is that, unfortunately, engineers a lot of times want to outsmart physics, and it doesn't happen, right? Because as a driller, I can delay physics a little bit, but I can't outsmart it. And it requires me to be more precise in what I do. The deeper I go, the more precise I have to be in the way I set my loop. The deeper I go, the more material I'm going to have to evacuate from that one position. The harder it is to be surgical, and even with a solids control system, not have to turn over my mud, right? Because if I have a hydraulic system, there's only so much I can go with a 6-inch before my mud weight is going to get to the point where maybe I finish drilling the hole, but I can't set a loop through that, right? If I have if I have an electrical system, I might be able to go a little deeper, but they're not, right? We're not running centrifuges. We're still going to gain mud weight. And mud weight is going to equal to more buoyancy. It's going to equal to that loop not wanting to go down the hole, which many times equals to where people struggle. Or we got to pump it off. Well, in an urban environment, I can't pump off. We got to figure out, where are we going with this? Did we pre-plan to have somebody come and be able to take it with us?
And that's, as we wrap up this brief Geothermal Drilling 101, the importance here is obviously drillers and engineers have to collaborate, and applying tribal knowledge to engineered specifications is a very important trait. And outdoing physics, we don't know what we don't know. So knowledge and understanding and embracing the science and physics, and then also stepping in and having a discussion and defaulting to trust and checking our egos. And my ego's huge, and I constantly have to go check your ego, Brock, check your ego, Brock, check your ego, Brock. But we can have the right discussions. We can build out the right drilling program. And this is just one discussion of many that will come from this. But it is very important for us to see the collaboration needed to be successful at drilling.
And, I appreciate you can check your ego once in a while. Because
you can't.
I can't. No, I can't. I'm the guy, right? No, in reality, we're here to provide a service. And we can only provide that service professionally if we pre-plan, if we do the things that are going to allow us to look professional. If I rail on anything, it's that we need to up our professionalism, right? Because we should be upping what we command for our service. We provide some of the most important services to man there is. So why should that construction company make more per hour than the drilling company has an equal amount of capital equipment invested, but we're gonna give it away? So if you're professional, if you pre-plan, you can command a little more money for your projects, because people would rather work with you than the guy who doesn't look surgical and clean, who says, hey, yeah, this didn't work out the way I wanted, right? Yeah, I want this change order. If they've done all the things they're supposed to do, all of that stuff is lessened. They look more professional. They have less projects that don't work out the way they're supposed to. Their employees are happier because they're not in a state of chaos all the time. And, our industry as a whole will grow and progress.
I think that's a big piece, is, as I'm going to wrap it here, respect the industry in all aspects. And the idea that somebody steps in on a project with $1.5 million worth of Capital X equipment in a high-risk environment to discover the unknown is the same as that master's degree in engineering or in science or in whatever feat that we're getting into. There's a great degree of risk involved in drilling, and we can do it right, but at the same time, there's going to be places where it's going to cost more than others. I want to thank you today, Dave, for coming out. Any last parting words?
Just that I enjoy talking to Brock egoless.
The fun thing about Dave Bowers, he's always angry. So this is why these things are always great. So this is Brock Yordy and Dave Bowers live at the Climate Master Climate Control Group booth. We want to talk more drilling. You can contact us, find us on LinkedIn, find us at thedriller.com. And we appreciate Climate Master and Climate Control Group allowing us this 20 minutes to have this discussion. Thank you for joining us for episode 94 of the Driller Newscast. Man, it's always great to sit down with Dave Bowers and talk training, talk about where our industry needs to go. And let's face it, we really need to be thinking about who's going to train the trainers and what those standards look like. There's a lot of opinions out there. And I know it's great to stand on the platform and be the execution on a job site, but now we need to think about how we can get other people on the platform and be able to walk away from that job site and them still be successful. And that's not by coming up with crazy one-way methods. It's looking at the holistic process of all drilling methods throughout the country with these centers of excellence. We got to be preparing our people for extreme weather. I want you to think about all we covered there, the 200 million people that were affected, the fatalities, the injuries, the car accidents we saw with Winter Storm Heather. It's a big deal. Check out thedriller.com. There's great content coming out daily. We're always looking for Ask Brocks, and check out the new Emerging Driller series and submit an upcoming professional who is kicking butt that should have a spotlight shined on them so we can get more great young professionals into this industry. Go out, be safe, have a great week.